I'm going to talk in quite a different way now. Not so much, well, it isn't about techniques in teaching so far, but more about thinking about uh, what modules, what programs, what development we should be doing to support not only space, but the whole sustainability issue and prepare young engineers for the future of engineering. So I've divided this, well, I've taken three, probably actually four aspects. There's the transition engineering aspect, and I shall talk a little bit in more detail about transition engineering and what that is in a minute. Um, about an MSc in engineering management that I've been putting together as part of a complete renewal of the programs in MSc engineering across the board at Glyndwr, and to consider the opportunities and the issues around the future needs and how that should be represented within master's level education. And added to that is obviously the sustainability issues and the Earth observation issues, and those will come up too. So motivations. From a sustainability point of view, we need to mitigate climate change issues, reduce climate change, keep things in control so that we don't have catastrophic breakdown of civilization and destruction of the world. I mean, that sounds trivial and trite, but actually that's what's going to happen if we're not very careful. And to manage that will require data and metrics in order to be able to understand progress and what's working, what isn't working. And this is where Earth's observation is such an important and powerful tool. So this is where the space industry really gives value in terms of sustainability when we're thinking about sustainability of the planet, sustainability of civilization, and so on. So thinking about that from the point of view of students and about future careers, use of data and metrics demands capability in data analytics. So this could be in computer science as much as it could be in engineering. And it also requires thought leadership. And by thought leadership, I mean people who are able to speak confidently. And our last speaker talked about the importance of being able to present a very good argument, to be able to present it in a convincing way. So there is that aspect. And a lot of the time in engineering, we so much focused on, can you do finite element analysis? Do you know about the strength of materials? It's all the mathematical and all the sort of head down difficult stuff, rather than the way one presents oneself and the way one puts arguments together. So it's a much broader range of capabilities. It's not just the boffin work, it's the politician work that we need to get our engineers, those with the talent for it, to become more capable in. So we want a smart new generation of young people who are going to be the engineering leaders of the future. And when we're talking about 2050, the students who are coming through our universities now are going to be the senior members of engineering profession in 2050. They're going to be the leaders, the people who push us through and keep the planet going. And so we've got to be giving them the right tools. So I think there's a lot of a lot of capability that needs to be brought together, and it's time to do that and think about what do we mean by engineering management and really change that around. Uh, and actually at Glyndwr, when we've been discussing how we should name this program, there's been a lot of argument about the terminology, because management suggests that the management of the business department ought to be running something and they should be talking about HR activities and all of that sort of thing. And it's far more than just the interpersonal stuff. I mean, it's bits of everything really. Management of resources, ethical management, management of supply chains, is right across the board, and one can't possibly cover everything in one simple MSc degree, especially one that is constrained by what is possible within a small university. So I shall move on a little bit. We'll come back to these thoughts in a minute. Um, Wrexham Glyndwr University is probably the smallest university in the UK. I mean, I don't know for sure, but I wouldn't expect any other. I wouldn't have thought a university is really feasible any smaller than ours. But within that, engineering is one of the bigger discipline areas. And in the MSc cohorts this year, we had about 60, 70 students across all of the engineering disciplines. So that's important. It covers things from the mechanical, manufacturing, aerospace, automotive, the electrical side of things, and renewables. So a whole load of technologies and skill types, and all of those combined to make one cohort. And for the efficiency of teaching, one wants to provide a certain core of standard modules plus some options that are interchangeable between some groups, so that the teaching load doesn't become huge, because some of these topic areas, some of these degree programs will have less than 10 students in them. I think it's also pertinent to mention that a large part of our final year in the BEng are from European students, mainly from places like Germany and Spain, France, where students have, in those countries where there's something like the old 11 plus system, where students who didn't pass the 11 plus went into a technical program. In those countries, it's difficult for students who have been late developers, who've discovered a capability in engineering and have gone down the technical route. It's very difficult for them to transition from being in a technical route to an engineering qualification route. And one of the ways round that they've found is to use the qualifications they have to come across to Glyndwr University with a top-up program in the summer, and then enter straight into the final year of the BEng. And they usually do extremely well. Most of those students get 2-1s and firsts, and it really bolsters the numbers and makes it possible to offer more options in third year than we would otherwise be able to do. So always around, everybody's a winner, and it's been a really good advantage. And those students, usually they've come from an industrial job where they've been working in a technical role for a few years, and discovered that this is the point where they want to change their career and move up. So they are mature students. They're coming this with a very good focus on what it is they want to gain and where they want to get to. So they're very motivated, and they will typically follow on to do an MSc. And if they haven't had such a strong industrial background beforehand, they will go back and do a job from their BEng, so work for a few years, and then come back a bit later to do their MSc. So we have a lot of returners from the BEng program into the MSc. So it makes a lot of sense for us to have that structure rather than having an MEng structure, a 4-year degree program. This seems to work very well for those students, and they are a large part of the cohort. So, I mean, there's a lot of students, and this applies to the British students as well. A lot of them will go and get a job straight after BEng and come back after a few years with more confidence and much more focus. And the university's ethos is really about student confidence. And we do have a lot of students who've gone into good careers following our program. So they do very well. You might think that a small university like ours with limited options would be not such a strong output, but actually the students seem to do extremely well, and they are well recognised by the employers they have. I also want to mention St Asaph campus. So mostly we're based in Wrexham, and that's where all the teaching takes place. But on St Asaph campus is a big research hub, and a big part of that is the Precision Optical Systems group, and they're working in telescope mirror polishing work, so very, very high precision optics, and so it is used for astronomical and for satellite instrumentation. So we do have some aspects in space, even though we haven't got an explicit space degree program. I'll give you a few examples of things that are done that are space related, but not actually part of a dedicated space program. So we have flight simulating capability, and we've got a strong computational fluid dynamics research activity in the team. And as a result, the more capable students gravitate towards doing things where they can do interesting simulations of flight. And this particular student is one of the German cohort, I believe, has done his project on re-entry. So the aerodynamics involved for re-entry onto Mars. And I don't know to the extent to which his research work is really credible, but it's great to see students working on commercial level software, trying to solve real engineering problems that relate to space scenarios. Another one is a PhD student recently graduated, whose work was on tethers, and the idea is to use a tether with a stabilizing smaller mass, which is ejected from the spacecraft, and the tether is gradually extended, and depending on the rate at which the tether is extended, you get different stabilizing behaviors of the overall system as it re-enters atmosphere, and that can lead to higher degrees of accuracy and lower impacts as the spacecraft lands. So it's a case of making it a much smaller search area for actually capturing the vehicle when it's landed. Um, Obviously, the student is Russian, and we had a very good relationship with Samara University. And it's actually, I'm very unfortunate what's happened in the recent years with the recent few months over Ukraine, which has actually meant that we are no longer actually actively collaborating at the moment. But Russia had a really good research program for young Russian scientists, and uh, this work was all on the back of that. So it doesn't look a very interesting picture, but the mathematics behind that is absolutely fascinating. The third one is about the St Asaph campus and the precision polishing, and to give you an idea of some of the activities and the applications. Um, they have mirror polishing, probably they're global experts on mirror polishing to very, very high tolerances. So we're talking in the order of magnitude of tens of nanometers. So the length of maybe 10 atoms in a crystal is that degree of accuracy. So very high surface finish, which is what you need to be able to get the best resolution imagery. So moving on to transition engineering, it's a new discipline area, and it's been emerging over the last 10 years, I suppose, um, developed to address sustainability, the sustainability of the fuel supply, the fossil fuel supply, and the carbon dioxide load in the atmosphere, and to believe that if anything's to be done about this, then engineers have got to be at the heart of doing whatever it needs to be done. This development was started by Susan Kromdiek around 2010, and then in 2014, the Global Association for Transition Engineering was created. So that's another sort of engineering professional body. And about the same, a bit later on, that Susan wrote the first textbook on the subject and developed an MSc program that's run from University of Christchurch in New Zealand. I think she's looking to see this becoming more widespread. But what strikes me at this point in time is it's a small body of people doing things, and it's becoming entrenched into what their views are. And the only way for it to grow is for it to expand a lot more and be absorbed by other people. And on the one hand, I see this as a really, really solid and serious attempt. And there's a lot of useful concepts and tools in the textbook that will take it further. But it's also a launch point for anybody who wants to build a new career. So it could be a launch point for a PhD student to say, where are we going with this? What can change? How should it grow? And it's also a point where young people who are going through their education can pick up on the tools and the ideas and put them together with other things, more longer existing aspects, and say, well, yes, that fits in a role, but there's these things as well. I mean, thinking of things like Six Sigma and statistical process control in manufacturing on the one hand, and thinking about things like innovation skills. How do you create new ideas? um, Systems engineering. There's a whole range of different areas where this should become engaged and become part of and build from, and that needs to happen. So I see this is an exciting point in time for somebody coming through MSc, entering the beginning of their career, learning in a new job, and applying this tool amongst others and developing this as a much broader capability. So we can have a discussion about transition engineering, and I hope that that's something we do a bit later on. So why MSc in engineering management? And this comes back to the point about the students being more mature, and it's actually something they're asking for. They ask for engineering management because they see that management is the way forward for their careers. Um, but when we start saying, well, what do you mean by it? Uh, it's a much broader brush. And again, this has been the discussion that's been going on at the university about what we should be naming this degree programme. Things that are important to the students are things like leadership. What does leadership mean? What does management mean? What are the difference between the two? And also this responsible experience that's required as part of the chartered engineer registration in the UK spec, or the equivalent that might be required in the your ING um, registration, so more common abroad. And then there are certain technologies that they really all are very interested in, and most of the students I know are talking about Industry 4 and Internet of Things, sensor development, automation, those sorts of things. This is where they're most interesting at the moment. So those are more along the technological capabilities. And a common theme with all the students is about the environment and the future, and how much they are worried about it and how much they want to do something about it. And that's why they've entered engineering. That's their motivation for engineering, which is quite different to our day, where it might have been, oh, to be able to build a better aircraft, or to build spacecraft, or to create faster cars. The motivations of the younger generation have changed. So what they're looking for is a career that fits their values. That brings us right back to sustainability. And Wrexham Glyndwr has a master's program already on the sustainable technologies, but that's on the technology side of it rather than on the managerial side of it. So I think we've got a good fit where shared modules can provide both to the students who are particularly interested in that area. Now, I should say something about my own take on what I think of engineering management, or what I think should be wrapped up within that. Thinking about the constraints of the degree programme, it has to be broad and thin because of what's the sort of university we are. We basically have the budget for two 20-credit modules, and the rest of the programme is made up from the core programmes and the options that are available to all the students in that overall cohort. And I'm thinking the transition to more sustainable uh, living capability. So what our civilization needs to carry on in a comfortable way, good quality of life for everybody, but using fewer resources. To eliminate, certainly to reduce and to eliminate fossil fuels, and engineering management skills that will make that happen involve innovation, planning, leadership, resource management, and the list goes on and on and on. The technological side of this, the capabilities, those can fit within the core and options diet of modules that are currently available. So those who are interested in computational mechanics, they can do CFD and finite element modules. Those who are interested in renewables can look at some of the renewables, electrical engineering modules, and so on. And these are available to all. They also have a diet of 2 core modules, one which is specifically on innovation, the other one which is on um, preparation for research. And then, of course, the 60 credit dissertation project is aligned to whichever topic area the student wants to take further. And finally, I've had to put this slide in last because this is only something that's become recently available. In Wales, the Welsh government has been very, very strongly helping and pushing to develop a bigger footprint in space in Wales. And as a part of this, they have very recently built a collaboration with the company Planet for their Earth observation data. So they are one of the leading providers of high resolution satellite imagery. And that resource has now been made available to all Welsh universities. Um, and when I say recently, I mean 6th of June. I've barely had time to get my head around what's capabilities there and think about how to use it. So I haven't actually planned it into the MSc module, but I really see a great opportunity to do so. And I hope we can also spread some of that joy to the computer science department, because I think there's going to be masses of high quality data analytics work to be done with that as well. But at this point in time, I'm just stunned that this is available and we can use it, and I'm still thinking about how to use it. So finally, just to say thank you all very much. If you need my contact details, they're there, but I'm sure anyone from the Sun community can put you in touch.
Thank you very much, Alison. So I thought it was quite interesting that you're coming from a non-space specific degree program. Sustainability isn't just about the space environment, although that's clearly a very important aspect now, reducing debris, not creating more debris. But also it's about how we manufacture spacecraft, rockets, etc. on ground. So there may be other people that we are interacting with, students that we're interacting with, who will go on to have a role in the space sector, even though they haven't started from that point of view. So I think that's really interesting. And I think it was quite interesting just to hear about, how do you include sustainability into the curriculum? Do you make it a module and talk about sustainability very heavily within a module, or do you try and weave it through everything that you talk about? So there's other things to think about there. And we all probably know colleagues in departments that aren't space-based. So again, there's an opportunity to go and talk to them and offer them space-based examples of sustainability that they can include in any of their programs as well. So I thought some really interesting thoughts for me came up through that, at least.
Thank you. I mean, as a very small university, we can't afford to be experts in anything. We might have individuals who've got some expertise in particular slots and so on. But what we really want to do is give the students a taster of as much as possible, and show them the tools for becoming the specialists that they want to become.